In this video, we're going to talk about the different parts of similar triangles. All right, we've talked about similar triangles a few lessons ago, and we talked about how the sides of the corresponding sides of similar triangles are proportional. Well, the same thing is true with other parts of similar triangles. All right, so you might ask, what are some other parts? Well, you have parts like the altitudes of the triangles, or the angle bisectors of triangles, or the medians of triangles. Okay, so that's what we're talking about there. So the first theorem, theorem 7.8, says if two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. Remember, the altitude is the line that goes from one of the vertex down to the side that's opposite of that vertex, and crosses that side at a right angle. All right. So whenever you see a right angle in a triangle, you know you're talking about the the altitude. You can tell you can talk about the altitude. All right. Um, so then you might say, well, what are the angle bisectors? Well, an angle bisector is just simply the line that goes from one side to the angle that's opposite of it, and in splits that opposite angle exactly in half. Okay, so it splits the angle in half. So, and theorem 7.9 says if two triangles are similar, the lengths of the corresponding angle bisectors, the length of from R to T, is proportional is proportional to QR or RS, or whatever. And the same thing goes with LP, proportional to KL and LM. All right. Pause the video and copy these two theorems into your notes. All right. So the next theorem we're talking about, that says if two triangles are similar, the lengths of the corresponding medians are proportional to the length of the corresponding side. So remember, the median here is just simply the line that goes from the vertex over to the side that's opposite of it and splits that side exactly in half. So it's a a segment bisector rather than an angle bisector. Okay, so so wherever it hits that opposite side, the two segments on either side of it out to the vertex are going to be congruent. All right, and the last theorem that we're wanting to copy into our notes here is the triangle angle bisector, and it just says that an angle bisector in a triangle separates the opposite side into two segments that are proportional to the length of the two sides. Okay, so in other words, KM right here is is um, the ratio of KM to LM is the same as the ratio of KJ to LJ. All right. So pause the video and copy this into your notes. All right, so given that two triangles are similar, find the value of x. Once again, we notice here that this is the median, all right, because this and this are those two segments on either side of the line are congruent to each other. Okay, same thing with the other one. So we know that if we go back to our to the um, to the median here, okay, we know that CD is going to be proportional to YZ, all right, or it's going to have the ratio YZ, and then the two sides are going to be are equal to going to be proportional. Okay, so we know that this and this are going to be the ratio. I'm going to write it as 8 to 12. is equal to, now because we have that 5 here, okay, so that's going to go 5, 2, and here's our x. It's going to be the 5 to x. And when we cross multiply, we have 8x from here to here, okay, and then is equal to 12 times 5, all right? So we know we can figure out that 12 times 5 is 60, and we're going to divide it by 8, all right? So that tells us that x is equal to 60 divided by 8, all right? 60 divided by 8 is equal to 7.5, all right? The next one says these are two altitudes. So I'm going to say the altitude of 6 to 9 is equal to x to 21, all right? And we're going to cross multiply, all right? So we're going to go 9 to x, and we're going to go 6 to 21, all right? So we're going to say 9 to x is 9x, 6 to 21, all right, is 9x is equal to 126 divided by 9. X is equal to 126 divided by 9 is 14. Okay? The next one, we'll talk about the angle bisectors. All right? So you notice here, these two angles are congruent, and as well as those two. So we're going to come up with the ratio of 9 to 10 is equal to x to 18. So we have 10x is equal to 9 times 18. (162) divided by 10. X is equal to 16.2. Okay? Alright, so the next one, we see here that we have, once again, we have our angle bisectors here, but we don't know what the length of the line is. Okay? And we don't know that. This comes back to that last theorem that we wrote down, the triangle angle bisector theorem, that says an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the length of the two sides. Okay, so what that's saying there is that if I, oops, is that this, and this, okay, are proportional to this and this. So we can say 12 to 26 is proportional to 8 to m. All right, cross multiply. All right, so 12 times m is 12m is equal to 8 times 26. All right, when we do that, 8 times 26 is equal to 208. So 12m is equal to 208. I'm going to divide by 12. All right, 208 divided by 12 is 17.333, and that continues to repeat itself. So we're just going to leave that. We're going to round that off to the nearest 10th place. Okay, it's one decimal place. Look to the number to the right is a 3, which tells us to leave the 3 alone. Okay, those tells us to leave the 3 as a 3. All right. The next one, and the last one that we're doing, is a little bit trickier because we're given the total length, but that total length also involves the x. Okay, so we know that this, so we're going to have x is proportional to 30, okay, is a ratio to 30, and we know that over here we're going to have something is equal to is a ratio to 20. Well, what we don't know is what is the length of this side. Well, it's just simply this whole 28 with the x value taken out. Okay, so it's the whole length with this x value taken away from it. So that gives us the expression of 28 minus x. All right, so then we cross multiply. X times 20 is 20x is equal to 30 times 28 minus x. And then we have to distribute, okay? So 30 times 28 is 840 minus 30 times x is 30x. And over here we still have 20x. All right. We're going to add the 30x, add the 30x. All right, this cancels out. The reason we add it is because it's a negative. Okay, 20x plus 30x is 50x is equal to 840. And we're going to divide by 50. All right, so 840 divided by 50 gives us 16.8. Okay, these 50s cancel out. X is equal to 16.8. Okay. All right. So that does it for this lesson. Your classwork should have an example for each one of them. So make sure you ask questions if you don't understand something. We'll talk to y'all later.